to look at writing linear equations from word problems. So the first thing we're going to look at is writing from slope-intercept form from a word problem. So as you may remember, slope-intercept form is y equals mx plus b. And how we know we have slope-intercept form is when we are using a rate of change. So m will be the rate of change in the problem. And we have a starting point, which will be b. Just kind of like you have on a graph, b is your starting point, and then m is the rate of change or movement. So this first one, it says, Evan is going to the country fair this weekend. The admission fare to the fair is $5 and the cost per ride is 50 cents. If his parents gave him $20, write and solve a linear equation to find out how much he can go on. So what we're going to write, y equals, and y is going to represent the grand total. That's usually what happens here. And then m is going to be the rate of change. B is the starting point. So the starting point would be the time they enter the fair. So when we start or go to the fair, our starting amount that we have to pay is $5. So that will be our B in the problem, the $5. The cost per ride, so that's the rate of change or the rate for each ride. So 50 cents, what we do have to remember is 50 cents is 0.5, so that is going to be our m, so 0.5x. So then what we're going to do is solve. So they give us this problem here. If we have $20, how much can we go on? So 20 is the goal. We're going to substitute in 20 for our y, and that's going to be 0.5x plus 5. So to solve, we're going to subtract 5 from both sides. We get 15 equals 0.5x. We're going to divide by 0.5, and that is going to give me x equals 30. So the most he can go on is 30 rides. So again, we're looking for a starting point and a rate of change. So number 2, while visiting Crimson Lake, Sally decided to go kayaking. The ranger charges $8.50 per hour in addition to a $25 deposit to rent the kayak. So these are our two numbers right here. So which one is M, which one is B? So if it's $8.50 per hour, that is the rate of change because this is a rate over some sort of changing time. So M is 8.5. And then that's on addition to the $25 deposit. So that's a one-time fee or the starting point. If we want to rent a kayak, we have to start by paying $25. So B is our starting point, 25. So an equation would be y equals 8.5x plus 25. So then it asks if she rented a kayak from 11 a.m. to 2:30 p.m., write and solve to find the total cost of the kayak. So remember, y is the total cost. We don't know how much that is. In this original one, this was the total, so we could plug it in for y. What we're dealing with here is the time. We don't know how much it's going to cost, but we do know we want to rent from 11:30 to 2:30, and that is a total of 3 hours, right? So 3 hours going on here. So I'm going to substitute that into x because x is per hour, right? It's $8.50 per hour. So I'm going to have 8.5 times 3 plus 25. So when I put that into my calculator, it says that a total cost for renting the kayak for 3 hours is $50.50. So for 3 hours, it will cost $50.50. All right, so now we're going to look at standard form. So remember, standard form is ax plus by equals c. So remember, our variables are x and y, and these are going to represent two different objects in a problem. So when we're dealing with two different items in a problem, that is when we will have standard form. So for example, it says Sam ordered 2 hamburgers and 3 hot dogs. So right away, we'd see we're dealing with two different things, hamburgers and hot dogs. So what I'm going to do to start this problem is label which one is which. X is going to represent my hamburgers, and Y will represent the hot dog. So that's just going to help me keep track of what's what in the problem by labeling at the beginning. So he orders that from the concession stand, and his bill came to $19.05. So we're going to write an expression or an equation to represent this total cost or this purchase right here. So it says 2 hamburgers, so that would be 2x, 3 hot dogs, so 3y, and together, which is why there's a plus sign, their total cost was $19.05, right? So that's going to be the equation to represent. Now it's suggesting if hamburgers cost $5.25 each, figure out how much it would cost for each hot dog. So this is why labeling at the beginning is so important. Hamburgers are the X, and I'm going to substitute in $5.25 for those hamburgers. So 2 times 5.25 plus 3y equals 19.05. 2 times 5.25, that's going to give me 10.50 plus 3y equals 19.05. Now I need to solve for y by isolating the variable, so I'm going to subtract 10.50 from both sides. So that's going to give me 8.55, and then I divide by 3, and I get y equals 2.85. So remember, y represents our hot dogs, so for my sentence, I'm going to write the hot dogs cost $2.85 each. Okay, so next one, tickets to a school play cost $4 in advance, $5 at the door. So we see here we have 2 options for tickets, advanced tickets and at the door. So we can go ahead and label our variables X. We will just call the advanced ones, and Y is going to be at the door. Total ticket sales for an event or an evening production were $440. So we're going to go ahead and set up an equation representing this scenario. It costs $4 for the advanced tickets and $5 for the at the door, and we know that we sold $440 worth. So now our scenario, it's saying if no tickets were sold in advance, write and solve an equation to find how many were sold at the door. So remember, advance is our X variable, and selling none of them would be the number 0. Remember, 0 represents nothing. So I'm going to do 4 times 0 plus 5y equals 440. Now, 4 times 0 makes 0, so this kind of just goes away, right? Anything plus 0 stays the same, and I'm left with 5y equals 440. So I'm going to divide, and I get y equals 5 goes into 40 8 times with the 4 left over, so 5 goes to 40 again, another 8 times. So y represents tickets at the door, so the answer is there were 88 tickets sold at the door.